You can't have 5 bonds to carbon. It's hideous. Look away. Formal charge. You have to be able to look at an element and know exactly what the formal charge is without hesitation every time. In order to do that, there are some common charge patterns for the elements that we're going to look at. We're going to organize this in terms of the number of bonds to that element and the number of lone pairs on that element. The number of bonds plus the number of lone pairs will tell us exactly what the formal charge should be. Let's look at the halogens. With the halogen with a negative charge, this is going to be just a halogen with 4 lone pairs and 0 bonds. That gives the halogen a negative charge. A halogen with a neutral charge is going to have 1 bond and 3 lone pairs. That's going to give the halogen a neutral charge. Anytime we see a halogen with 1 bond and 3 lone pairs, we know immediately that's going to be a neutral halogen. A halogen with a positive charge, we don't see very often, but we do see it every now and then. That's going to be a halogen with 2 bonds and 2 lone pairs, giving that halogen a positive charge. For oxygen, if we have an oxygen that's negatively charged, we call that an oxide. That's going to be an oxygen with 1 bond and 3 lone pairs. A neutral oxygen is going to have 2 bonds and 2 lone pairs. And a positively charged oxygen is going to have 3 bonds and 1 lone pair. That's called an oxonium ion. There's a bit of a pattern developing here. Can you see the pattern? Let's see if that pattern holds while we go through the nitrogens. A nitrogen that has a negative charge is called an amide, and it has 2 bonds and 2 lone pairs. A nitrogen with a neutral charge is going to have 3 bonds and 1 lone pair. And a nitrogen with a positive charge, an ammonium cation, is going to have 4 bonds and 0 lone pairs for a positive charge on nitrogen. Go ahead and see if you can fill in this column for carbon. Pause the video now, see if you can fill in the column for carbon. Carbon with a negative charge, we call a carbanion, is going to have 3 bonds and 1 lone pair, giving carbon a negative charge. Neutral carbon is going to have 4 bonds and 0 lone pairs. What did you put in this cell? Did you put 5 bonds to carbon? Did you say carbon with 5 bonds is going to have a positive charge? Carbon doesn't make 5 bonds. You can't have 5 bonds to carbon. It's hideous. Look away. It's hideous. Don't look at it. Get rid of it. In order to have a carbon with positive charge is going to have 3 bonds and 0 lone pairs. This is the only one that doesn't quite fit our pattern here. So be careful. Carbon doesn't make 5 bonds. A carbocation has 3 bonds and 0 lone pairs. These are the charge patterns we need to be very familiar with. We need to be able to look at an element, know exactly how many bonds, exactly how many lone pairs, even if the lone pairs aren't always drawn in, to know what the formal charge on all of these elements are.
I'm glad you're here with us for this training today. Check out these other videos in my playlists to see if there's anything else that can help you level up your ninja levels even further. As always, don't forget to like and subscribe.